Hey guys, welcome back to some more OCR FSMQ. Joe back at it once again. This is the start of the past papers. Now, I made this PowerPoint quite a while ago, so there may be some mistakes in it, but this is the June 2007 paper that we are going to be doing today. So the learning objective is going to be the same for all of the past papers. We're going to analyse a past paper. Sorry if you just heard that beeping in the background. To analyse a past paper and see how we would do. So let's get on to the first question. So nice and easy, solve 3 brackets x plus 2 close brackets is greater than 2 minus x. So what we do here is expand the bracket first and we end up with that. So 3 times x is 3x and 3 times 2 is 6 and that is greater than 2 minus x. Now what I'd do here is take over that x and take over that 6 just to make sure my x is a positive, so I end up with that 4x is greater than minus 4, so divide both sides by 4, I get x is greater than minus 1, and that has grabbed yourself a couple of marks at the start of an exam. They do like the inequalities to start up to get you, settled down. Question 2. A particle moves in a straight line, its velocity in meters per second, t seconds after passing a point O, is given by the equation v equals 6 plus 3t squared. Find the distance travelled between the times t equals 1 and t equals 3. Well, first thing to spot is that it's velocity in terms of time. So we know that we're going to be using calculus in this, and we're talking about distance. So if you remember, the relationship between velocity and distance is via integration. So you differentiate s to get v, and differentiate v to get a, and then you integrate back. So here we go. So v equals 6 plus 3t squared. Then we know if we integrate that with respect to t, between 3 and 1 we can get the distance. You can integrate with respect to t and work out an equation for s and then work from there, but you'd have c's involved. But if you think about if we have with c, well, we'll talk about that in a second. So here we go. We'll integrate between the limits of 3 and 1 of 6 plus 3t squared with respect to t. So add 1 to the power, divide by the new power, and we end up with 6t plus 3t cubed over 3 between the limits of 3 and 1. But those 3's can cancel because they're on top and bottom. So we end up with that, 6t plus t cubed between 3 and 1. And remember, we'll put with 3 in, we'll put with 1 in, and we'll take the answers off each other. And we'll end up with that. So 6 times 3 plus 3 cubed minus 6 times 1 plus 1 cubed, which is 38 meters, because you've got 18 add 27, which is 45, minus 6 add 1, which is 45 minus 7, which is 38. So there we go. Grabbed yourself another 4 marks in the exam, I think it was. 38 meters for integration between limits. Now, what I was talking about before, somebody asked this on the integration between limits video. Well, with the c, you would have a plus c there. And if you think about it, when you put your 3 in and 1 in, you'll get a c there, plus c, and a plus c there as well. And when you minus them off, it'll just be c minus c, which is obviously 0. So we'll just forget the c when we're talking about limits. You can put it in if you want, just to be technically correct, but yeah, we just forget about them when integrating between limits. So here we go, number 3. A circle has the equation x squared plus y squared minus 4x minus 6y plus 3 equals 0. Find the coordinates of the centre and radius of the circle. So there we go, that's that horrible piece of algebra that we've just been given. Remember, when you're given it in this form, we have to halve the coefficients of both the x and the y and put them inside a squared bracket. A squared bracket, not a square bracket. So we say x minus 2 all squared, but remember, when we expand this, we'll get an x squared and we'll get a minus 4x, which is what we want, but we'll also get an unwanted plus 4, so we have to take away that 4 to make sure that we only have this left. So it's that all squared minus 4 and then plus y minus 3 all squared, but we'll get an unwanted plus 9, so we have to take away that 9, and then plus the 3 because he hasn't been touched yet. And I'll just get rid of that ink momentarily. So there we go. It's perfect. So now we've got x minus 2 all squared, add y minus 3 all squared. Minus 4 minus 9 is minus 13. But add another 3 and you get minus 10. And then take him over the other side and it becomes a positive 10. Now remember, the generic equation for a circle is x minus a all squared plus y minus b all squared equals r squared. So our radius in this case must be the root of 10, which is root 10. And the centre, remember, it's the opposite of what's in the bracket. So if it's minus 2, it'll be 2. And if it's minus 3, it'll be 3. So it's a circle with the centre 2, 3, and radius root 10. So that's how I'd do that question. Number 4, find all the values of x in the range 0 degrees to 360 degrees that satisfy sin x equals minus 4 cos x. Now remember, you cannot solve a trigonometric equation if there's two pieces of trig in the same equation. So what we have to do is we'll have to manipulate that to only have one piece of trig in there. Now there's a couple of things you can do, but personally what I would do is divide everything by cos, like that, because I'm going to get a cos over cos on this side, which will just cancel out and become 1. And remember, if you remember back to the trigonometrical identities lesson, any sin x over any cos x will equal a tan x. So we'll get tan x equals minus 4, and then we can solve as normal. There's one piece of trig, and we go like that. Shift tan it in the calculator, and the shift tan of minus 4 will possibly be a minus answer. I'm not entirely sure, but yes, it is. It's minus 75.96. But remember, we want it in the range of 0 to 360, and tan solutions come every 180 degrees, so we add 180 onto that, and we get that, which is 104.03. But if we add another 180 onto that, we also get 284.03. So there are your two answers. We get that and that. So there you go. You can get yourself another 3 or 4 marks there, I would say. In future PowerPoints, I do have the marks on there, but these are all available on the FSMQ website if you log on. So number 5, a car is travelling along a motorway at 30 meters a second. At the moment that it passes a point A, the brakes are applied so that the car decelerates with a constant deceleration. When it reaches a point B, where AB equals 300 meters, the speed of the car is 10 meters a second. So calculate the constant deceleration and the time taken to travel from A to B. So list your variables. It's suvat because it's constant deceleration in this scenario. So we've got suvat along the top, if you remember from our equations of motion lesson. So read the question. So now I'm told an initial speed of 30, like that. I am also told, what else am I told? I'm told a distance, 300 meters. And I'm told the final velocity is going to be 10. So there we go. And we want to work out the constant deceleration. So I turn to this equation, v squared equals u squared plus 2as. Remember, you have to learn these equations, so you should have learned them by now. So we've got v squared equals u squared plus 2as. We need to rearrange that to get a on its own, but I'm going to just plug the numbers in first. So v squared, 10 squared, is going to be 100. U squared is 30 squared, which is 900. And 2 lots of s is 2 times 300, which is 600, and that's glued to the a. Take people over the other side, and you get 100 minus 900, which is minus 800, and divide both sides by 600, and you get minus 800 over 600, which cancels down to minus 4 over 3 meters per second squared for acceleration. But remember, it's a deceleration, so we're sticking a negative on the front. So that's the first part of the question done. Now we need to work out the time taken to travel from A to B. So I'm going to use v equals u plus at. You could have used s equals ut plus a half at squared, or any other equation you know for time. But here we go. Plug in the numbers. So 10 equals 30 minus 4 thirds of t. Take the 30 over the other side, and times throughout by 3. So you'd get minus 20 times 3, which is minus 60. Got a negative on both sides, so we can just make them positive and divide both sides by 4. So you get that, which is 15 seconds. So another okay question in terms of difficulty. As long as you've learnt your equations of motion and how to go about them, it's all formula work. So question 6, we're rattling along nicely at a decent pace. Well, we're saying that we're about 10 minutes into the video. These are going to be longer ones because obviously it's a 2-hour exam. I can't get through it in 10 minutes. But here's question 6. Find the equation of the tangent of the curve y equals x cubed minus 3x plus 4 at the point 2, 6. So y equals x cubed minus 3x plus 4. And remember, when we're finding the equation of the tangent, we need a gradient and a known point. To find the gradient, we're going to have to differentiate it with respect to x and put the x coordinate through. So dy by dx equals 3x squared minus 3, because remember, power to the front, knock 1 off the power. So the 3 comes to the front, and we take 1 off the power. So it's going to be 3x squared, and power to the front, knock 1 off the power. Anything to the power of 0 is 1, so it's just going to be minus 3, and the 4 disappears. Now we'll put our x coordinate through, so when x equals 2, dy by dx equals 9. It's tangent, so that is going to be our gradient that we use. And then we turn to the lovely line equation, y minus b equals mx minus a, or some of you might have been taught y minus y1 equals mx minus x1, but I prefer using b and a. Put in with numbers like that, y minus 6 equals 9x minus 2. Expand the bracket and you get that, and I like my x to be positive, so I'll take the 6 over to join that, and we'll get y equals 9x minus 12. But once you get to this point here, any acceptable form is fine. So if you had y minus 9x equals minus 12, or you had y minus 9x plus 12 equals 0, any acceptable form, but that is the universally accepted one really, y equals 9x minus 12. So there you go, that's the end of that question. Question 7. Use calculus to find the x-coordinate of the minimum point on the curve that. So, remember, to find stationary points, we need to differentiate and set equal to 0, and if it's a minimum point, it's going to be a stationary point automatically. So we get that. dy by dx is that, so 3x squared minus 4x minus 15. Remember, we have to set that equal to 0 because it's a stationary point. So you get that. And then you solve that. And that actually factorizes to 3x plus 5, x minus 3. And that's equal to 0 still. So your x coordinates must be minus 5 over 3 or 3. And now, there's a little extension to this question. It wants to find the minimum point. So we have to, if you remember the odds and ends lesson I did, to find min and max points, you have to differentiate it again and put the x coordinates through. And, well, we'll talk about that in a second. So we find a max slash min by finding the second diff. So if we diff it again, d squared y over dx squared is 6x minus 4, power to the front, knock 1 off the power. And therefore put a minus 5 thirds through and a 3 through. When x equals minus 5 thirds, the second derivative is negative, therefore it's a maximum point. That's a confusing thing, it's the opposite of what you would think. But when it equals 3, the second derivative is positive, therefore it's a minimum point. So x, the x coordinate must be 3. And that's all we needed to do because it only wanted the x coordinate. So that's another question done. Question 8. Now you can see I've stopped typing up the questions and just copy and pasted the actual paper in. The figure shows the graphs of y equals 4x minus x squared and y equals x squared minus 4x plus 6. So use an algebraic method to find the x coordinates of the point where the curves intersect. So remember, curves intersect when their algebra is equal to each other. So if we see a y is equal here, we can paste that in for any other y that we see. So there we go. So what I've done there is pasted the 4x minus x squared in for the y here. and called it 4x minus x squared equals x squared minus 4x plus 6. Rearrange that and you get 2x squared minus 8x plus 6 equals 0. You can divide by 2 if you want there, like I did. X squared minus 4x plus 3 equals 0. And that factorizes beautifully to x minus 3, x plus minus 1. So therefore, our x coordinates must be 3 or 1. And we only wanted the x coordinates again, so that's all we have to do. Now then, calculate the area enclosed by the two curves. So if you remember, we'll find the area by doing the seal and take floor, and we've just worked out with goalposts because the meet here, here, and here, and they're going to be the goalposts because that's the only place where this little area lies in between. So we do the integration between 3 and 1 of the seal and take the floor. Now the ceiling in this case is going to be the N shape, and the floor is going to be the U shape. So a negative x squared graph always produces an N shape, and a positive x squared graph always produces a U shape. So that's how you remember, and that's how you can tell in an exam. So the seal and take the floor is going to be that minus that. So careful of your double negatives here. So it's going to be 4x minus 4x, so it's going to be 8x. It's going to be minus x squared, so it's going to be minus 2x, and it's just going to be 0 minus 6, which is just minus 6. But remember, we're integrating that between 3 and 1 with respect to x. So add 1 to the power, divide by the new power, like that. And we'll put with 3 in, we'll put with 1 in, and we'll subtract the answers, and we'll get that. So we'll end up with 54 over 3 minus plus 36 minus 18 minus 2/3, add 4 minus 6, and that ends up being 8 over 3 units squared. So it's not very nice, but put all of that calculation in the second squared bracket here into your, forget the 3 and the 1 at that point, into your Casio calculator, and it should come out with 8/3 units squared. Remember, it's units squared because it is area. Right, so that's question 8 done, and that was 7 marks there. And well earned 7 marks as well. So question 9, the points A, B and C have coordinates -1, 1, 5, 8 and 8, 3 respectively. Show that AC equals AB. Now these are classic questions in the OCR FSMQ. I've seen at least 3 or 4 exactly like this, and they usually go on to talk about circles, but since I've already played that card earlier in the paper, they won't do that here. But here we go. Remember, the length of a line is back take back squared added to front take front squared and rooted. So we end up with that, which is root 85. Now AB is that, and that's also root 85. So therefore AC must equal AB. So that's a nice easy 2 marks if you've learnt your formulas. Second part, write down the coordinates of M, the midpoint of BC. Right, so that's the midpoint equation, but you should really be able to just spot it. So it's front add front over 2, back add back over 2, or just the average of the x's, average of the y's, which is what I do. And you get that, and you get that. So 13 over 2 and 11 over 2. Or, if you like working in decimals, 6.5, 5.5. So back take back over front take front, because if we're going to show perpendicularity, we're going to have to find out the gradient. So BC, back take back over front take front, you end up with that, which is negative 5/3. And AM is that take that over that take that, and that's apparently 3/5. May have made a mathematical error. I think I do actually remember doing this wrong in the lesson. So you guys will be able to spot the mistake, but the gradients do end up being that. Now remember actually doing that on my piece of paper, because I do them on paper before I upload them to the PowerPoint. So it's -5/3 and 3/5 are your gradients that you'll end up with. And they are they are negative reciprocals of each other, therefore they are perpendicular, if you remember the gradient theory. But finally, find the equation of the line AM. So y minus b equals mx minus a. 3/5 is the gradient of that, and the point of a is minus 1, 1, so I'm just using that. And you get that, because the times through it by 5, and then expanded the brackets. And then you get that, which is 5y equals 3x plus 9. I think that might be wrong, actually, because that should be a 5 there. So that would make that an 8. Double check that on the mark scheme, guys, and let us know down in the comments below. But yeah, I think that's right now, because yeah, that's right. So times by 5 and you get that, and then you take that over the other side and you get 5y equals 3x plus 8. Sorry I made a little bit of a mess of those last two parts, but you get the idea. The gradients are right, and at the end I've managed to actually fix the question. But they are classic questions in the OCR exam. Question 10 then. By drawing suitable graphs on the same axes, indicate the region for which the following inequalities hold. You should shade the region which is not required. So you're given a bunch of inequalities. This is screaming out linear programming, and I would be clapping my hands if I got this type of linear programming in the exam, because I don't have to read through a novel of text and pick out information. You're just given it on a page, and it's simply about drawing a set of axes, getting that. You'll be given this in an exam, the graph paper, and usually the scales as well. But there we go. Remember the cover-up method. So if we cover up that, we get 3y equals 12, so y must equal 4. And if we cover up that, we'll get 2x equals 12, so x must equal 6. And then join them up, like that. Wants to be under the line, so we shade above. But we're going to draw in the lines first, because I like doing things in the wrong order. And y is always greater than 0, and x is always greater than 0. And we'll shade out like that. So our little region is this down here, like that. So that's the first bit done. That's 5 marks for drawing that graph there, which is pretty good, I'd say. So find the maximum value of x plus 3y subject to these conditions. So let it equal a number that's friendly to both of them. We'll let that equal that. So x must equal 3, like that, and y must equal 1, like that. So the maximum is at 0 minus 4, because if we keep going out and out and out and out and out, this will end up being the point. But remember, go in a parallel fashion with your arm on the screen right now, and just go up, and that will be the maximum point. So we'll put that back through where objective function, so it'll be 0 plus 3 lots of 4, which is 12, and that's the answer. So that's question 10 done. Number 11 then, that's just a curve sketch which we'll come on to in a second. So A, you were given that f of x equals x cubed minus 3x squared minus 4x. So find the 3 points where the curve y equals f of x cuts the axes. So if you've got that, we can take out a common factor of x and do that, and then factorize that. So the points where it must cut the axes are at x equals 0, x equals 4, and x equals minus 1. So there you go. That's the first 4 marks for factorizing a cubic, which isn't too difficult, that one, actually. So very good. And then sketching the graph, so it's obviously a positive cubic that goes through minus 1, 0, and 4. So there you go. And now you were given that g of x is that. So find the remainder when g of x is divided by x plus 1. Now, I just put the minus 1 through because it's remainder theorem. You could have divided them and worked out the remainder at the bottom, but it's just a bit time consuming. So we'll put minus 1 through, because remember, you do the opposite of what's in the bracket. And you get minus 1 cubed minus 3 times minus 1 squared minus 4 minus 1s plus 12. So lots of double negativity here, and it ends up being 12. So that's the answer for that one. Show that x minus 2 is a factor of g of x. Because it's going to be a factor, I'm going to actually divide this, because I think I see where this is going. So I do this. So I ask myself, what do I times that by to get that? And I say x squared, and I put that up top, and I times throughout. So I do x squared times x, which is x cubed, x squared plus 2, which is 2x squared, and then I subtract down, so x cubed minus x cubed, they'll die. That take that is that. So then I ask myself, what do I times this by to get this? I say minus 5, and then minus 5x, and then I times throughout, and I'll get minus 5x squared minus 10x. Subtract down, so they die, like that. And then you get minus 4x minus 10x, which is positive 6x, plus 12. So I ask myself, what's that? What do I times that by to get that? I say 6, and then I times throughout, and I get 6x plus 12. When I subtract them, that dies, that dies, that dies, that dies, so I'm just left with 0. And you put in brackets there, as expected, or therefore it is a factor. And then hence solve the equation. So we've now got that as a factor, and we've also got this quadratic at the top here, which we're going to have to solve. So we'll stick them next to each other. That'll always factorize usually, so you get that. So with 3 solutions for x, a minus 2, a 3, or 2. So that question there is fairly easy for question 11, to be honest with you. It's fairly time consuming, but you've got yourself 12 marks there, which is very good, I'd say, for this part of the exam. Question 12 then. The workforce of a large company is made up of males and females in the ratio 9 to 11. 1/3 of the male employees work part-time, and 1/2 of the female employees work part-time. Both work part-time. 8 employees are chosen at random. Find the probability that all are males. So a trial here is 8 employees. So for males, x can be binomially distributed 8, 0.45, because 9/20ths, if we add those up, we'll get 20. 9/20ths is 0.45. For females, its x can be binomially distributed 8, 0.55. So that's that. Find the probability that all are males. So that's the p of x is equals 8, because it's 8 people. So we do 8c, 8 times 0.45, which is with success, to the 8 times failure to the rest. So we do that, and we get that, which you can round if you want, but I just left it like that, I think. Hold on, what have I done here? I don't know why I've done that, but maybe that is the female one. Perhaps, I don't know where that's really come from, but exactly 5 are female, so that's the p of x equals 5. I don't think I've done this. That's a terrible equals 5. Don't think I've actually done this, no. Right, so there we go. That'll be 8c5 times 0.55, because that's one new success. 0.55 to the 5 times 0.45 to the 3, and that equals 0.257. Check that on a calculator, double check that that's actually right. I think it is, but anyway. So, part 3, at least 2 work part-time. So we're now talking in the realms of part-time. So the probability of somebody working part-time is, if we look at it, so it's going to be 9/20ths for male, and 1/3 of the male employees work part-time. So it'll be 9/20ths times 1/3. So that's the probability of you being a man and working part-time, because and in probability is times. So it's 9/20ths times 1/3. And then adding that to 11/20ths for the females times 1/2, because it's 1/2 of the female employees that work part-time. So the probability of somebody working part-time is 17/40ths. Right, so now we want at least 2 people working part-time, just any gender, just at least 2. So the part-time can be distributed binomially 8, 17/40, because that's what probability of a success. Now remember, being at least means 2 or more, and if we get our number line, we grab 2, we shove all them out the way above, so we're just left with 0 and 1. So 1 take the probability of x being less than or equal to -1 equals the p of x greater than or equal to 2. So that's that. 1 minus the probability of x equaling 0 and x equaling 1. So 17/40 to the 0 times 13/40 to the 8. Success to what I want, failure to the rest. Same for that one. Like that should be a plus in the middle. Apologies about that. So you end up with that, which is 0.917 in the end. So quite a difficult question, that one. Binomial distribution is always a little bit fidgety in these exams when they get to this part of the question. Apologies about part 2 of that question, but I think that is right. But you can tell that I made this quite a long time ago because I can't remember the mistakes I actually made. But part 1 and 3 are right. So here we go. Question 13. And one of the worst questions on the paper, actually. 3D trig. I'm not a great fan of it, but here we go. Calculate part 1, the lengths OM and CM. So we've got this pyramid OABC, and we're given some lengths. M is the midpoint of AB, which is there. So we know that's 12, and we know that's 12. Big deal. So OM is this line here. If I can just shade it in, it's going to be this line here, O to M, and CM is that line here. Now we're given that there, 40 centimeters, so that's probably going to come in handy at some point, but let's see what I've done. I did Pythagoras actually. OM squared equals 37 squared minus 12 squared. So if we think of this as a right angle triangle, we've got the 37 here, that's going to be the hypotenuse, minus the 12 there, and that's going to be OM squared, so we'll get that, which is 35 centimeters. So we can now write this in, so OM equals 35, and CM is going to be similar. We're going to have 20 squared minus 12 squared, because it's this here, and that's going to equal 16 squared, 16 centimeters. I beg your pardon. Well, it does actually, 20 squared minus 12 squared is actually 16 squared, but the CM is actually 16, because of the root of CM squared is CM. So there we go, we've got ourselves 3 marks by just remembering Pythagoras. So I'm actually going to get rid of all the ink and call that 35 and call that 16. Right, so the angle between the line OC and the plane ABC. So OC is this one, and the plane ABC is that. So I called it that angle there. And now it's going to be cosine rule, because we've got this side here, and this side here, and we want the angle. So we'll get that. Cos A equals B squared plus C squared minus A squared all over 2BC. You are actually given the cosine rule in the exam, so just rearrange it on the day to get cos A, and you end up with that, which is that. Once you've shift cosed it, you've got 60.5. So I know this angle here is 60.5, and that's going to come in handy for the next question. So the volume of a pyramid is given by 1/3 times the base area times the height. So the base area is going to be half the base times the height. We know the height is 16, and we know the base is 24. So it's going to be half of the base times the height. So it's going to be half of 16 times 24, which is 192 centimeters squared. So that's the base area. Now we need the height. So the height is going to be this line here. So from O all the way down, creating a right angle with this here. So we know that angle there. We want that distance, and we know 40. So using a bit of trig, the height is going to be 40 times sin 60.5, because we want the opposite, and we have the hypotenuse and we'll have the angle, so it's going to be opposite equals sin 60.5 times the hypotenuse, which is 40, so we get that, which is 34.8 centimeters. And then putting in what we know, it's going to be third times the base area times the height, and it ends up being 2,228 centimeters cubed for volume. But that is a bit of an intense question, and you're probably getting tired by the end of this, so mistakes can happen, and that's how they try to catch you out. But that's question 13. There's one more question, I believe. Question 14. Now this is an absolutely lovely question. I really enjoyed doing this one. So an extending ladder has two positions. In position A, the length of the ladder is x meters, and when the foot of the ladder is placed 2 meters from the base of the wall, the ladder reaches y meters up the wall. So there you go. You end up with that. Use Pythagoras' theorem for position A and position B to write down two equations in x and y. So we've got position B here, position A. So Pythagoras said that square that, and you get that squared. So there we go, that's what I'm going to do. X squared must equal 4 plus y squared, because 2 squared is 4, and y squared is y squared. And for that one, x plus 0.95 all squared will equal 4 plus y plus all of that squared, which is that. So there are your two equations for 2 marks, not bad. So hence show that 2.1y equals 1.9x minus 0.2. So if I know that x squared equals that, then what have I done here? Hold on. let us realise what I've done. I think I've literally just expanded. Hold on a second. Forget I said anything about this being x squared. All I've done there is expanded this bracket and this bracket. So there we go. I've done that and got that. So x square the first, square the second, twice the inner product. That's where I got that from. Square the first, square the second, twice the inner product. So that's twice the inner product. There you go. And now I know that x squared is actually 4 plus y squared. So I can replace this with this and call it that. There you go. 4 plus y squared equals that. I've just tidied all of this up, by the way. Took him over the other side. And we end up with that. Sorry if you're not keeping up here, but watch it a couple of times and you'll see what I've done. And then here, I'm going to get... what am I going to do? I've done that. Oh, I want the 2.1y squared on its own, don't I? Because that's what the examiner wanted, remember. So one eye on what the examiner wants. So I've got this on its own. So I've punted him over the other side, him over the other side, him over the other side, but he's going to become a minus, so he can just go. And we end up with 4 minus 4.2 plus that is equal to 2.1y. And if we tidy that up, we end up with that, which is what the examiner wanted, and that's where you breathe a big sigh of relief because you got what the right answer and 3 more marks in the bag. But you're not done yet. I'm just going to get rid of all of the ink so far. So here we go. Using these equations, form a quadratic equation in x. So hence find the values of x and y. Right then, so we know what y will equal if we take that 2.1 under there, and we know that x squared equals 4 plus y squared. So if y equals, I'm just going to write that down here, 1.9x minus 0.2 all over 2.1, then we can paste that into there and square it, and you will end up with that. Now then, very, very intense algebra coming up. So it's going to be 1.9x over 2.1 squared minus 0.2 over 2.1 squared, and then twice the inner product, so we'll have to times them together and double them, so you end up with that. And then times everything by 2.1 squared to get rid of that as a denominator. So you end up with that. 2.1 squared, by the way, is 4.41. So you get 4.41 x squared equals 4.41 times 4, which is that. And then you get 1.9 squared x squared plus 0.4, because that should be a squared there, remember. Because when you square the first, square the second, twice the inner product, you get that. 0.2 squared over 2.1 squared is that, and then minus that. So there we go, we've ended up with that. Tidying up, fingers crossed, things will work out nicely. You end up with that, which is not very nice. So 0.8 x squared plus 0.76 x minus 17.68 equals 0. The only thing I can see there is quadratic equation, so we're going to have to go minus 0.76 plus or minus, you have to learn this by the way, the square root of 0.76 squared add 4, sorry, it's minus, my mistake. Yeah. So, hold on. Minus 4 times 0.8 times minus 17.68. So, because of the double negative there, that would have actually been an add, so it wouldn't have made any difference. And that's all over 2 times 0.8, which is 1.6. So when you do that, there you go, quadratic equation, and you type that into your calculator, and you end up with x equals 4.25 and y equals 3.75 once you put that x back in. But you will get a negative value for x as well, but remember you cannot have a negative length, so that's how that works there. But that is the June 2007 FSMQ paper. Now, it was an intense paper, but it's actually one of the easier ones on the course, and if I remember correctly, it's about 73 for an A on this paper, so you had to score pretty well. It's out of 100. But there you go. If you have any questions down below in the comments or any feedback on the videos, then feel free to leave that down in the comments. The next paper is June 2008, and that will hopefully be up in the next couple of days. And we're going right up to June 2014. I don't know if OCR are going to make the 2015 paper available anytime soon, but if they do, I will also do that paper. And I'm going to try and get a couple of practice papers from the revision guide up, and a specimen paper as well, just so you guys have as much material as possible to see. But I hope you guys have enjoyed this episode and found it helpful. Please leave a like if you did. It'll tell me that you find these helpful, and spurs on to do more. And yeah, subscribe if you're new, of course. I've got all the lessons that I taught my class up on the up on the channel. I'm not a qualified teacher, so do bear that in mind. And yeah, thanks for watching. Good luck with your FSMQ, and goodbye.